Welcome to this explainer. Today, we're diving into architecting infrastructure. Specifically, we're going to break down the AWS CloudFormation blueprint. Let's jump right in.
Picture this scenario. A junior developer accidentally deletes your production database subnet, system offline.
Your CEO runs in visibly panicked and asks, "How long until we are back up?" Now really think about your answer here.
If you built your system by manually clicking around the AWS console, the answer is days. You'd have to remember exactly how every single security group, routing table, and gateway was manually wired together. But if you used AWS CloudFormation, you just press enter and your entire infrastructure rebuilds itself flawlessly in exactly 5 minutes.
So, the core mental model you absolutely need to grasp, especially for the exam, is pretty simple. Infrastructure can and honestly must be deployed exactly like software. You do not treat servers, load balancers, and databases as physical hardware anymore. Instead, you treat them as lines of text in a JSON or YAML file. This right here is what we call infrastructure as code, or IAC for short.
To actually use AWS CloudFormation, you're going to create a text file, which is called a template. Think about it like this. The template is basically the architectural blueprint for a house. It defines exactly where the walls go, where the plumbing is, and how many windows you have. But as we all know, a blueprint is just paper, right? It isn't an actual house. When you hand that JSON or YAML blueprint over to AWS, CloudFormation acts as your construction crew. It reads the code and physically builds the environment. And in the AWS world, that finished deployed environment is called a stack.
Now, inside your template, the only mandatory section you absolutely must write is the resources block. This is where you declare exactly what you want, like say an Amazon EC2 instance or an S3 bucket. But here's the kicker. You do not write complex scripts. You don't write the underlying API calls. You simply declare your desired end state, and CloudFormation figures out exactly how to make it happen for you.
Think about that for a second. You don't have to write custom code to check if a VPC exists and then wait for it to be ready and then attach an internet gateway. CloudFormation inherently understands dependency ordering. It mathematically maps out your resources, realizes the VPC has to exist before the subnets, and builds them all in the absolute perfect sequence automatically. It's really that smart.
Now, imagine this. Let's say you need a development environment, a staging environment, and a highly available production environment. So do you go and write 3 separate, massive YAML templates? Absolutely not. You write one single template and you use the parameters section. Parameters allow you to inject dynamic values into your template right at the exact moment you hit deploy. So you pass the value t2.micro for the dev stage and m5.large for the production stage. Just like that, you have one repeatable code base creating infinite, perfectly identical environments.
And when that stack finishes building, you use the output section to export data, like the ID of your brand new VPC. Why? So that a completely separate CloudFormation stack can read that exact ID and deploy its own resources securely inside it. It connects everything seamlessly.
Now here's where this gets really interesting. What happens when your deployment actually fails? Let's say you deploy a stack. It creates 10 resources perfectly, but then the 11th resource fails because you hit some AWS account limit. Does AWS just leave your account littered with half-built, broken infrastructure?
No, definitely not. CloudFormation triggers what's called an automatic rollback. The very moment a failure occurs, CloudFormation reverses direction. It systematically deletes the 10 resources it just created, safely returning your AWS environment to its exact previous state. It is a strict all-or-nothing deployment, meaning you never have to go in and manually clean up broken resources.
But listen closely, because this is where people mess up. And honestly, it is how you will destroy a production database if you aren't careful. Let's say you have a running stack, and you need to update the storage size of an EC2 instance. Well, if you just blindly edit your YAML file and push the update, CloudFormation might completely delete the old instance and recreate a brand new one from scratch just to apply that change. Doing that would wipe out all of your data in the process.
To prevent this massive headache, as an AWS developer, you absolutely must use change sets. A change set is essentially a preview. It analyzes your newly updated template against the currently running stack and gives you a highly detailed report of the exact blast radius. It explicitly warns you, literally saying, if you execute this deployment, I will modify these 2 resources and I will permanently replace this specific database. You review that change set, verify it's completely safe, and only then do you actually execute the deployment.
Now, watch out for the ultimate production trap on the exam. You've deployed your perfect infrastructure as code. Everything is managed beautifully by CloudFormation. But at 2 a.m., a panicked engineer logs directly into the AWS Management Console and manually changes a security group rule to fix a live bug. Suddenly, your code and your reality no longer match. Your YAML file says port 80 is closed, but the live server has port 80 wide open. This nightmare scenario is called configuration drift.
To fix this, CloudFormation provides a feature called drift detection. You just click a button, and AWS instantly scans your live stack, flagging any single resource whose actual physical configuration has drifted from the expected state defined in your code. Your job then is to take that manual console fix, write it back into the YAML template, and redeploy it. That way, your code goes back to being the ultimate source of truth again.
Okay, let's lock this down with 3 rapid takeaways from this explainer. 1. CloudFormation uses declarative JSON or YAML templates to build and manage entirely repeatable environments, which we call stacks. 2. You safely update running environments by generating change sets. This lets you preview the blast radius before you apply any modifications. And 3. You use parameters to dynamically inject values for multi-environment deployments, and you use drift detection to catch any manual changes made outside of the codebase.
I want to leave you with one final warning. Never manually delete a resource in the console if it was created by CloudFormation. If you do, the next time CloudFormation tries to update that stack, it will panic, it will fail, and you will spend hours trying to manually untangle the broken dependency graph. Always update the code. Because think about it. If your code isn't the absolute truth, are you really controlling your infrastructure, or is your infrastructure controlling you?